So we're looking at the graph f of x equals negative x squared minus 9. That quantity has a negative x squared. So I'm just going to rewrite this as negative x squared plus 9. By distributing it out, this is more of the common form we were looking at. And things we should know, the negative says it's opening down. The 9 says it was a vertical shift. So it's a vertical shift up here. Our vertex is at 0, 9. So we're going to go through and answer some questions, true and false, about our function. So is the function decreasing when x is greater than 0? So any value where x is positive, or on this side of the graph, is the graph decreasing. And if we look at the slope, that is negative, so that is true. The axis of symmetry is at y equals 0. That would be false, because y equals 0 is actually the horizontal line. It'd be x equals 0. Anytime we have axis of symmetry, it's that x equals the value. The maximum value of f of x is 9. That is true. It reaches its peak right here. 2, 5 is the solution of f of x. So we're going to plug in 2 for x. So f of 2 equals negative 2 squared plus 9. That's going to be negative 4 plus 9, which is 5. So that is true. Negative 1, 3 is the solution. If we look at negative 1, we get negative times a negative 1 squared plus 9. That's negative 1 plus 9, which would be 8, which is not the solution. So that's false. 3, 0 is an x-intercept. If we look, 3, 0 is where it hits. So that is true. 0, 9 is an x-intercept. That is false. What's actually a 0, 9, it's a y-intercept. So we're going to say false. The axis of symmetry is x equals 0. That is true. That kind of fits B up here. So that's true. F of x opens down because of the subtraction sign before the 9. That is not the case. It's because of the negative x squared that it opens down. So that is false. Vertex is 0, 9. That was true. And the value of x when f of x reaches its maximum is 0. Reaches its maximum of 9, x is 0. That is true. Okay, our next set. Using f of x in the first problem, let's identify some more things. The domain of f of x is all real numbers. The range is the y values that exist. If we look, the maximum y value is 9, and everything below that exists, nothing above. So we're going to say the range is y is less than or equal to 9. The rule for translating the function, if we look at our values, the x values stayed the same, but we had a vertical shift and a reflection. So the vertical shift means we added 9 to the y value, but a reflection means we did the negative of the y value. So the negative y would be a vertical reflection, and then a 9 moves it up. So we'd write negative y plus 9. You could technically also write as 9 minus y. The average rate of change from 0 to 1. So if at our points we have 0, 9, and 1, 8. So the average rate of change is going to be the slope between those 2 points. Slope is change in y over change in x. So that'll be 9 minus 8, because that's the change in y, and 0 minus 1. So we get 1 over negative 1, which means we have a slope of negative 1. The average rate of change from 2 to 3. Our point at 2 is 2, 5, and 3, 0. So we're going to go change in y over change in x. We get 5 minus 0, and 2 minus 3. 5 over negative 1 gives us a slope of negative 5. So we can clearly see the rate of change between 2 and 3 is a lot more than 0 to 1, which we should. 0 to 1, it looks like this. 2 to 3, it's a lot steeper line. Number 3, we have our values. Let's sketch out our values in our function on the graph. So we have negative 6, negative 7. That doesn't look like it's going to be on the graph, but negative 5, 0 we can work with. That's here. Negative 4, 5. Negative 3, 8 would be up off of the graph. About right there. Negative 2, 9. Again, further off. Negative 1, 8. Back down. 0, 5. Hits here. And then 1, 0. So we can kind of see it looks like this approximately. Okay? So the x-intercepts. X-intercepts are where it hits the x-axis. That will be at -5 and +1. So -5, 0, and 1, 0. The y-intercepts are when the x is 0. It's where the y value that hits, and that is right here, 0, 5. The x value when it's at its maximum, well, if I know the vertex is -2, 9, the x value at its maximum is -2, and the maximum value is 9. K of x is increasing. It is increasing on this left side of it, so it's when it is less than this line right here, which was our -2. So when we say x is less than -2, and it's decreasing on this side, that's when it's greater than -2. Increasing on this side, decreasing on that side. Okay, match the equation that reveals its information without changing the form. So I look here, I have a factored form, I have a standard form, and I have a vertex form. So first off, if I look at reveals the maximum value of m of x, that one I'm probably going to find with the vertex form the easiest. So 4a, or it'll be c will be 1. Reveals the zeros, the x-intercepts. That comes when it's factored. So we get that from the factored, so that would be 2. And then our last option reveals the value of m of x when x is 0. What's nice about this form is if x is 0, I just make these both 0, and I know it's 15. So that would be 3. Really the focus we have to be ready for is vertex form. Tells us nicely what the maximum is, 27. Factored form easily tells us what the x-intercepts or the zeros are, because we set these factors equal to 0. Okay, we're going to factor our equation here and to get the solutions. They kind of gave us a list of options to use. So 2x squared plus 7x minus 15. I multiply the first and last term here, and I get -30, and I need to add to 7. So what can I multiply to -30 that adds to -7? Let's get another piece of paper here. So if I look at that, I could do maybe a +10, -3. So we're going to go 2x squared plus 10x minus 3x minus 15. And what we did is we split 7x into these two numbers. Now we factor the first two terms, taking out a 2x, leaving with its x plus 5. Factor the last two terms by taking out an x, or -3, and we get x plus 5. Both terms now have x plus 5, so we take that out and write the leftovers, which is 2x minus 3. So our factors turn out to be x, we'll put a 1x plus 5, and a 2x minus 3. They don't necessarily need the solutions there, just want to be able to factor it down. For b, I have 5x squared minus 51x plus 10. I'm looking to multiply to 50. That adds to -51. Looking at that, since it's bigger, it looks like I'm going to do -50 and -1. So we'll go 5x squared minus 50x minus x plus 10. So we're going to take out a 5x in the first two, and I'm left with x minus 10. If I take out a -1 in the next two, I'm left with an x minus 10. They match. So we take x minus 10, comes out. We're left with 5x minus 1. So we'd write up here 1x minus 10 and 5x minus 1. For number 6, we're going to state the vertex and sketch the graph. All of these are in vertex form. So this function, the vertex would be 5, 2, because I take the opposite of the value within the parentheses of the x and keep the outside one the same. So I'd go over 5, up 2, we'll say it's approximately there. The negative out in front tells me it's going to open down. Okay, next one, my vertex is going to be 5, 2, over 5, up 2. And now, since the value out in front is positive, that means it's going to open up from that same vertex. Last one, C, I'm going to have -5, -2. So that puts me down here. It's a positive out in front, and that will open up. Number 7, we need to find the axis of symmetry on each of them. All of them are in vertex form. So part A, our vertex is -1, -3. Your axis of symmetry is x equals -1 because it is the x value in the vertex. For B, my vertex is -5, 7. So my axis of symmetry, and this is going to be x equals -5. For C, we get -4, -9. Your axis of symmetry is x equals -4. For number 8, for each of the following, is it a solution? So we're going to plug in the x value to see if we get the y value. So y equals -3 times 0 squared plus 1. We get -3 times 0 plus 1, which is 0 plus 1, or 1. Y does equal 1, so that is yes, that is a solution. Next we go y equals -3 times 2 squared plus 1, -3 times 4 plus 1. By squaring it, we get a -12 plus 1, which comes out to be -11, so that is no, it is not a solution because we did not get 37. Next one, we go -3, 2 squared plus 1. This is just like the previous. We got 4, which is -12, and -11. -11 matches, so that is a yes. Last one, plug in a 1. We get -3 times 1 squared plus 1. This is going to be 1 times a -3, and we get -2. So the answer is no. That is not a solution because we did not get 8. Number 9. We need to identify the parts of this graph. So if we look, the vertex appears to be right here. So our vertex is 0, 5. Since it opens down, that is a maximum. And the value of that maximum is 5 because it's the y value. There. The axis of symmetry is the line that cuts it in half. That is x equals 0. It is also the y-axis. The graph is increasing. If we cover half of it, it's increasing on this side. So it's increasing when x is less than 0. And it's decreasing when x is greater than 0. Because it would look like this. Number 10, we have the transformation of the graph from x squared to x plus 4, that should be squared, minus 2. So for this one, I'm going to take it and move it. Well, if I look at g of x, the vertex is -4, -2. So it moved left 2, down 2, and it still opens up. So the transformation is a horizontal shift, left 4 units, and a vertical shift, down 2 units. For number 11, we're going to do the same idea. We have a vertex now with 3, 1. So we're going to over 3 up 1. Still facing the same direction, still the same width. So this will be a horizontal shift of right 3 units and a vertical shift of up 1 unit. Okay, number 12. We have our graph f of x and g of x. This is f of x here and g of x. Which graph has a greater maximum value? Our maximum value on this one is at 3, -2. So its maximum value is -2. Our maximum value on this graph appears to be right here. This is where it changes direction. So it's 0, 3. So the graph with the bigger maximum value will be the y value in f of x, so we say f of x. Okay, the graph of x when g of x is at a maximum is greater than the value of x when f of x is at a maximum. So this one's saying which x value is bigger at the vertex. Well, this one's 3, this one's 0. So we're going to say that f of x is bigger, so g of x is not greater than. Okay, the x-intercepts of g of x. By what we have here, the x-intercepts is when the function hits 0, which appears to be at -1 and +1. It's where that graph hits the x-axis g of x being 0, and our x-intercepts. Okay, number 13, we need to state the zeros. In order to do that, we're going to go 0 equals x squared minus 5x minus 14. And factor, we're looking at a way to multiply to negative 14 that adds to negative 5. I'm thinking negative 7 and positive 2. So we get x minus 7, x plus 2, which gives us x minus 7 equals 0 and x plus 2 equals 0, or solutions of 7 or negative 2. Number 14, a ball is thrown into the air, and we have our equation here. Find the time it takes to reach the maximum height. I'm just going to draw out this graph as it goes in the air. I know this is time in seconds, and this is height in feet. Our vertex off of the equation is at 323 by taking from the vertex form. So this tells us the important things we need. Find the time it takes to reach the maximum height. It's going to take 3 seconds to reach the maximum height. Now, for this equation, what is the domain and what is the range? Well, certain things matter because I'm not looking at all real numbers or every possible value. So there's certain things that don't fit. Like I'm not going to look when time is negative or after it hits the ground. So the domain, we would have to figure out where it hits right here. We'll get to that. Let's think range first. What are all the possible y values you have? Your possible height is you could go from 0 all the way up to 23. So we're going to say it's between 0 and 23. That's writing as inequality, or you just say between 0 and 23. The domain, we know it's between 0, but we need to figure out what this value is. To do that, we're going to solve. So I'm going to go 0 equals negative 3 t minus 3 squared plus 23. I'm going to subtract 23 over. And then I'm going to divide by 3, negative 3, and get 23 over 3 equals t minus 3 squared. I take the square root of both sides, and I get plus or minus the square root of 23 over the square root of 3 equals t minus 3. So this is going to be simplifying radical form, so I'm going to multiply the top and the bottom by root 23, or sorry, root 3, and that gives me, that'd be 69 on top and 3 on the bottom. We then add 3 over, and we get an answer of t equals 3 plus or minus the square root of 69 over 3. It was just two answers, 3 plus root 69 over 3 and 3 minus root 69 over 3. So what that looks like, and normally on the test these would be nicer values, so it would come out likely be whole numbers, it would factor cleaner. But I'm going to go 3 plus, we're going to have the square root of 69 over 3. And this comes out to be about 5.76. We'll call about 5.8. If we did 3 minus the square root of 69 over 3, that's about 0.23. That doesn't fit the problem so much. We're looking at this. We're looking on the way down, so we would say approximately 5.8 seconds. So that's the time that the ball was in the air. Okay, number 15, we need to graph our function. It's negative 2 times the quantity x plus 1 minus 2. Our vertex is negative 1, negative 2. Domain is all real numbers. We know the graph opens down, so the negative 2. So the range goes off the y value. We're going to say y is less than or equal to negative 2. And our axis of symmetry is the x value in the vertex, so we'd say x equals negative 1. For 16, our x-intercepts, we have x squared minus 2x minus 15. I'm going to factor that. So multiplies to negative 15, that adds to negative 2. We like 5 and 3 and make the 5 negative. So we go x minus 5, x plus 3. And these give us two solutions of 5 or negative 3. So let's go 5, negative 3. Okay, now we need to find the axis of symmetry. Now, I don't really have a axis of symmetry is in the middle of these 2 points. So between 5 and negative 3, if I did the average of those 2 numbers, I get 2 over 2, or 1. So is this the middle? And it appears so. So that is actually your axis of symmetry. Your axis of symmetry is halfway between those 2 points. So that's going to be at x equals 1. Well, to find the vertex, we know it's 1 something because the vertex is on the axis of symmetry. So what I'm going to do is going to plug the 1 into my equation to find what the y value is at that point. So we got 1 minus 2 minus 15, and that looks like a negative 16. So your vertex would be 1, negative 16, meaning it'd be pretty steep going down that direction. For 17, we have x squared minus 4x minus 5. We'll write it out here. 0 equals x squared minus 4x minus 5. We're going to factor. Multiply us to negative 5. That adds to negative 4. Let's go x minus 5, x plus 1. This gives us solutions of 5, negative 1. So 5, 0, negative 1, 0. So our axis of symmetry this time is halfway between the 2, so that's going to be at x equals 2, which is also the x value in our vertex. So now we're going to plug 2 in to the equation. So that's 2 squared minus 4 times 2 minus 5. 4 minus 8 minus 5. We get negative 9 as our vertex, which would be probably down here, and then our graph would look like that. For number 18, we need to find the average rate of change for f of x, our function x squared. So I'm going to go x and x squared and compare. So 0 and 3, if I plug them in, I have 0 and 9. So our slope, change in y over change in x, is going to be 9 minus 0, 3 minus 0, which gives me 9 over 3, or a slope of 3. Now if g of x, my function is 3 to the x. So plugging in 0 and 3, 3 to the 0 is 1, 3 to the third is 27. Change in y over change in x gives us 27 minus 1, y minus y, and 3 minus 0. 26 over 3 is our slope for that. Now 26 over 3 is about 8.7. And it's really 8.6 repeating. So how are they different? So we could say g of x has a greater average rate of change, which tells us the slope of g of x is steeper than f of x. Okay, our last one here, we have our function. We need to sketch out what we're looking at. So a ball is hit, we can model it with the function. We label our vertex, which is 10, 21. And let's see what we need to find here. This is distance, and this is height, both in feet. So the ball starts at x equals 0, okay? Based on the function, what is the height of the ball when it's first hit? So what we're going to do is make f of 0 equals negative 0.02 times 0 minus 10 squared plus 21. We're basically plugging in 0 to figure out the height. So we have negative 0.02 times negative 10 squared plus 21. This becomes 100. So 100 times negative 0.02 gives us negative 2. And this comes out to be 19. So it's 19 feet in the air. Maybe they're standing up on a platform. Up there it is, when they hit the ball. So 19 feet in the air. It then goes up in the air, reaches its maximum height, and then goes out. What is the height of the ball when 30 feet from the tennis player? So this one, I'm going to plug in 30 to negative 0.02. So now we have 20 squared, which is 400. So 400 times negative 0.02 is negative 8. So we get an answer of 13 feet. So it's 13 feet for that one.